Hello, everybody. Today, we want to talk about applications of data analytics in economics. So, the data set that I have here includes only 6 variables: age, sex, BMI, children, smoker, charges. And how many observations do we have? Uh, Last row is 1339. So, we have 1338 observations. Now, what are these? These are characteristics of different people that have been admitted to hospitals, and this is how much the hospital charged them. So, age, gender, and BMI is body mass index, I guess. So, it's weight in kilograms divided by height squares in meters, how many children they have, if they're smoking or not, and then charges. So that's the data that we have. As always, we want to get to know our data first, and after that, we can do some other stuff. So here we are asked what's BMI for everybody, what's BMI for men, for women, average age for men, average age for women, and then different things like this, yes? So essentially on Q's question 2, we have to split data to 2 parts for men and women. We can do that already. Uh, or for this, we can just use average and average ifs. That's also possible. Let's practice average and average if. So for what's the average BMI? It equals average. Oops. BMI, I go to tab data, BMI, average BMI for everybody is 30.6. Yes. Now, what's average BMI for men? What's average BMI for women? So equals average ifs. And then, so it's going to be average BMI. And then sex must be male. Um, so here we have two data, exclamation mark. We get data for of them. 30.9. And then the next one is going to be exactly similar to this. So it's gonna, I can just also copy and paste the formula. So just change male to female. Okay, now that we know the average BMI for men, for women, and for everybody, let's do the same thing with age. What's average age? Equals average. And then I go to tab data, average age for everybody. It's average 39 years old. Okay. Uh, no shame there. Yeah. I'm 39 years old. And the average age of all of those people are 39. Here we go. What's the average age for men? Equals average ifs. And then we do average age for men. So we said age, and then this guy must be male. Average age for men, 38.9. Average age for women. So I can just copy and paste this formula. and then change male to female. Okay. So average age for men is 38.9, average uh, age for women 39.5. Question 2. Question 2 is about what's the average charges for everybody, charges for men and women, and then do the filtering for male and female. Let's do the filtering first. So I go to tab data. I under home. I go here. Once I select just male, and then I copy and paste everything to male. And the next one, I go back. And then here, I'm going to select all females. Copy it one more time and then paste it for female. Okay. Now I'm going to go to tab data and clear my filter because I don't want to have filter data anymore. Okay, now that I have male and female, I can do this easily as well. What's the average charges for everybody? I can say equals average charges for everybody. 13,207. What's the average charges for men? So I can just do this equals average, and then I can go to tab male, and then just select for the what's the average charges for women equals average um, charges for women. So I go to female and I just click on charges. So average charges for female is 12,500, for men around 14,000, and then for everybody is almost in between. Next one, test the hypothesis that charges is the same for men and women. We already split data. Let's do the t-test equals t-test. We want to test if charges are the same for men and women. So I go to male, charges, comma, I go to female, charges, comma, 2, 2. And I get this. So here, obviously, the p-value is less than 0.05. So we can say this. Since p-value is less than 0.05, we reject H0. Means of two populations are statistically different. Okay. Which one has a higher charge? Men, yes. Which one has a lower charge? Women. Okay, that was question 1 and 2. Question 3. Okay, so we saw that on average men get charges, more charges. Now, what's the average charges for everybody? What's the average charges for people with BMI greater than 30? What's the average charges for people with BMI less than 30? Uh, okay, how can we do this? Average charges for everybody, we already saw that, but one more time. 13,270. People with BMI greater than 30 and higher. So I can say this. Equals average hips. And then I go here. Data charges. I'll go back to here. BMI must be greater than 30. So BMI, I don't need this Q2, must be greater than or equal to 30. $15,552. Now let's do the same thing for people with BMI less than 30. So essentially it's going to be the same thing, but rather than this, I can just copy and paste this as well. I'm going to just change this to less than 30. 10,000. Sorry, 10,700. Yes. So we saw that people with higher BMI, which is essentially somehow means, for example, obese people, yes, they get charges, higher charges, yes, versus people who are not obese, they get lower charges. Now we want to test the hypothesis that charges is the same for people above and below 30. Now for that, again, we have to split data to 2 parts. Now, how we can split data in 2 parts is there are different ways. One way is that we can, let's say, source our data with respect to BMI and then select everything greater than 30 and then less than 30. That's one way to do it. There are like different ways though. So maybe we can, one way that we can make this BMI greater than or equal 30 and less than 30 is by sorting. The easier way is to just do the filter and then go to BMI. So this might be a little bit new to us. So here we're not going to do sort, we're going to do filter, and then here we can see the choose one, yes? So we select, for example, greater than or equal to, and then 30. And I click on apply filter. As soon as I do that, I get this, and then with Command A, oops, Command A, Command C, and then Command V, I paste it. I go back to data. Here on BMI, rather than this, I'm going to choose less than 30. Apply filter, close this, Command C, copy it. On tab BMI less than 30, I'm going to paste it. So as you can see on this tab, all the BMIs are less than 30, and on this tab, all the BMIs are greater than 30, yes. So that makes sense, that's a good thing. Now that I've done that, I can answer this question. Test the hypothesis that charges are the same for two groups of BMI 30 or higher and BMI lower than 30. I do the t-test. So what am I comparing? Hospital charges, yes. Between what groups? BMI greater than 30 and BMI less than 30. Comma 2, comma 2. It's very, very small. And then conclusion is going to be the same thing that we had here. So I can just copy and paste here what we had there, here. Okay, now that we answered this one, we go to question 4. Yes. Data cleaning. So in many cases, we have to clean our data. Our data is not prepared as we wanted, yes? Sometimes we might have missing values, not in this data set, but generally speaking, we might have it missing values. We have to take care of that. For example, here we want to do some changes. Create worksheet data 2. So we have this worksheet data 2, it's empty. So we want to do regression 1, regression 2. That's the goal. For that, before running the regression, we have to clean our data. What does that mean? So look at this data set. First of all, let me clear the filter. I forgot to do that, but here we go. Now, look at data set variable sex. It's female and male. In regression, you cannot have like words in between variables. I must convert this to 0 and 1, or this one 0 and 1. So on question 4, create a keep variable age as is, convert variable sex to binary variable, which takes value 0 when female and 1 male. Okay, let's do this. So tab, I go to tab data, I copy this first column, paste it on data 2. That was easy, yes. Next variable that we have is sex. For that, I'm gonna change it, yes. I'm gonna, as here, question 4, we have it here, convert variable sex to a binary variable which takes value 0 when female and 1 male. So I'm gonna say here equals, here I'm gonna say 6, and then here equals if this guy if it is male, then so we want it, for example, to be so if this guy equals male, then we want it to be 1, otherwise 0, yes. Oops, I'm getting error. Let's see what the error is. And then we can fix it. The reason that I got an error was that I clicked on the whole column. Yes, I'm gonna erase this and do it one more time. So the formula equals if, open the parentheses, I go back to the tab data. If this guy, cell on tab data, cell B2, if this guy equals male, then 1, otherwise 0. And now it works. So you shouldn't click on the whole column B. Just you gotta say if data exclamation mark B2 equals male, comma 1, comma 0. And then I'll do this. So Excel fills up everything for me. Yes, I don't have to, but it works perfectly. Okay. Then read the rest. Let's read the rest. Convert variable sex to a binary variable which takes value 0 when female, 1 male. We did it. Keep variables BMI and children as is. So BMI, I'm going to just copy this and then data 2, paste it. Next variable, children, data 2, paste it. Then next variable is smoker. Again, this is 0, 1. I want to, yes and no, I want to convert it. I want to convert this variable, so I'm gonna paste the word smoker. Let's see how the conversion works. Convert variable smoker to a binary variable which takes value 1 if smoker and then 0 otherwise. So I type equals if, I go to tab data, and then if smoker equals yes, comma 1, comma 0. So I see that beautifully it's done. Yes. So for example, to make sure that it's working fine, the first person is smoker, then many non-smoker, then row 13 is smoker again. Smoker, all no, 13, yes, good. And then what else? So convert variable this to this, and then keep variable, let's say, I guess charges as is. So I forgot to say that, but keep variable charges as is. Now this data is cleaned. There's no male, female. There's no yes and no. Yes, they're all numbers. Since it's all numbers, then we can do regression. So let's see how we can do regression. Use all independent variables to predict charges. And then predict charges for the variable for the below cases. Let's do that. So for regression, we go to data and we go to data analysis and then regression. Yes. So I click on OK. We have to go to this tab, but so here I'm going to use all the variables to predict charges. Data analysis, regression. We have input Y range, input X range, and then labels. And so here I click on this guy, and then I select my Y range. Y is the target variable, the variable we are trying to predict. So that's it. And then input X range. Input X range, that would be all variables, yes? Not charges, but everything else. So that's the X range. And we can see it's $A, $1, exclamation mark, $E, which is the last variable, $1339, which is the last row. So we got that. And then since I have the labels, I click on labels, and then I click on OK, and I get these answers. Yes. Now these answers, we have different numbers. The interpretation is very important. What does it mean that we got these numbers? Let me first of all zoom in a little bit so we can see the results better. Yes. There are many variables, many things that they mean different things. Some of them are a little bit like outside the scope of this course, but the important things, I'll talk about the important things that we have, yes? The most important variable that here we have is coefficients. That's the most important one. Let's see how it works and how it's done. Now, we got everything there. These are the different coefficients that we have. So if we had, for example, the equation, the way we can make this prediction is this. So first of all, maybe I can call this another word, yes? Maybe I can call this reg1 results, regression 1 results. So I know this is about regression 1. And then maybe I can just move it here. Like you can, change the order of tabs. Okay. Now, you know that the regression equation is something like this. Like the intercept, or B0 plus B1 times X1 plus all the way to the last variable that we have, Bn times Xn. So these are the coefficients that we have. B0 or intercept is this guy, and then B1 is going to be this guy, and then Bn, which is the last one, is this guy. So these are the coefficients. Then we want to, for example, have this number, and then with the help of them, we want to predict charges for these people. So I'm gonna just paste them right here. But pasting them right here is not gonna help me in this format that much. Essentially, I want to say this, for example, just imagine we want to do one prediction. How do we do that? Yes. So let's say just this prediction. The way it works, I want to say this guy plus this times this, plus this times this, plus this times this, plus this times this, plus this guy times this guy. So an easier way is to just copy this and then transpose paste it here. So I do the right click and then paste special transpose. Yes. And then for charges, I can say this equals this A7 plus this times this plus this times this plus this times this plus this times this plus this times this. And I get the prediction for the first person, 5,892, yes. Now, that's the first prediction that we have, 5892. Now, can I scroll this down and to get the calculation for everybody? Oh, damn it. I got like hashtag value error. So why? Whenever you get something like this, double click on it and see what the problem is. When I drag it down, not only this part drags down, but also this one. But I want these coefficients to stay the same things, yes? I don't want them to change. So I have to fix the row. So in the formula, I go back to the formula and I fix the row, the seventh row. So I'm going to say $7 7 $. I want to fix the row 7, but not the row 9. Yes, just row 7. Yeah, now it works. Yes. And now it worked perfectly, and I have all the predictions for everything. These are extra. I'm going to just delete them. But essentially, I ran the regression. I got the results here. Yes. I use this result to make the prediction. The prediction comes from the formula. The formula is this: beta 0 plus beta 1 times x1 plus beta 2 times x2 plus. And what are betas? Betas are these. This is beta 0, this is beta 1, beta 2, beta 3, beta 4, beta 5. What are x1, x2, x3, x4? This is like x1, x2, x3, x4, x5. And then I do the predictions. One more regression we have here, predict charges using only age and sex. So here the regression equation that we have is something like this. Predicted y equals beta 0 plus beta 1 times x1 plus, again, this is not a part of solution. This is just to tell you why we are doing this for instructional purposes. Again, it's not part of the solution, x2. So, for example, when you want to do just prediction for 36-year-old and 0 was, yes, 0 was male, yes. 0 was, yes, value 0 and female, sorry. 0 is female. So when you want to predict charges for 36-year-old female, you use x1 as 36 and x2 as 0. And then what are beta 0, beta 1, beta 2? You got to run the regression. So I go back to data, and then I want to do the regression one more time. Let me scroll up. And then we run the regression one more time. I go to data analysis. Okay. And then here, input y range is going to be the same thing, but I'm going to just run it for the sake of it one more time. You scroll all the y's that we have. It takes like a few seconds to get to the last point, but here we go. And then input x range. So what variables did we want to use? Age and sex. Yes. So for x, I'm going to just do this. By the way, your X variables must be adjacent. Like you can't use, for example, age and BMI because they are not adjacent. They must be adjacent, like age and let's say sex in this example. Variables physically, but must be adjacent. So I got that one. And then again, I have labels. So I click check this one. And then I want my result to be on a new worksheet. So I keep that one. And then I just click on OK. As soon as I do that, I get this. So this is regression 2 results. I'm going to rename this tab to regression 2 results. And then maybe I can move this tab to here, make it a little bit bigger. Yes. Now I got all the coefficients. I copy them. Go to tab regression 2. And then right here, I'm gonna paste special transpose. Nice. Now all I gotta say is this. I'm gonna delete these question marks. So equals this plus, so that's beta 0 plus beta 1 times x1 plus this guy times this guy. And I hit enter. Now, again, if I scroll down, it's not going to work because I didn't fix the row. So I go back to this formula. And whenever I have 7, I'm going to put $sign before them. Here we go. So these are the predictions that we have for these 5 individuals. Yes. Which prediction would be, like, let's say, closer to reality? Of course, the first one, yes, because here I use way more information, and BMI, children, smoker, those variables are very important variables determining hospital charges. So these predictions are going to be like way more accurate than these variables, these predictions. Yes. Okay. That's it for today. Thank you very much, everybody, for listening. I hope you learned a lot, and thank you. Enjoy your time.